Good morning, students. I hope I am audible to you. Am I audible to
Sir.
you?
Yes, sir. Yes, sir.
In the last class, what we have done, we derive the expression of induced EMF. Right? Derive the equation of induced EMF. What we have done in the last class, we derive the equation of induced EMF. That is, Eg is equal to E phi n j by A. In the last class, we have derived the equation of induced EMF in DC generator, that is Eg is equal to P phi Nz by 68. And what is the N? N is what is N? Can anyone tell me what is N?
Rotation per second.
Rotation, actually a revolution or rotation of what?
So per second.
N is speed of armature, in RPS. And now we consider capital N. What is the capital N? It is speed of armature in RPM. So what is the relation between small n and capital N? Can anyone tell me? Can anyone tell me what is the relation between capital N and small n?
Sir, small n is equals to capital N by 6.
Capital N by 60. So how we do that? Because suppose consider capital N is equal to 60. Suppose 60 RPM. Then what is the value of small n at that time? So what should be the value of small n? 1 RPS. Is it clear to you how we do that? Is it clear to you?
Yes, sir.
Okay. That means suppose a fan is rotating with a speed of 60 RPM. That means it rotates 60 times in a minute. Then what is the value of rotation in a second? Is 1. That means a fan is rotating with speed of 1 RPS, then it will rotate in minute is 60. So the relation between small n and capital N is n small n is equal to capital N by 60. So we can write now the induced EMF equation is P phi capital N Z by 60A. what is this equation, or what is the name of that equation? What?
Induced EMF, sir.
Induced EMF equation. Okay. And now tell me what is A? What is A?
Parallel path between two brushes.
A is the number of parallel paths between two brushes. Based on A, we can classify the machine as wave wound machine and lap wound machine. Based on A, we can classify machine two types. One is called wave type or wave wound, and lap wound. If the value of A is 2, then this type machine is called wave wound. And if the value of A is equal to number of poles, then this type machine is called lap wound. Have you get my point? What I'm saying? If the number of parallel path is 2, then this type machine is called wave wound. And if number of parallel path is equal to the number of poles, then this type machine is called lap wound. Is it clear to you? Is it clear to you?
Hello, sir.
Yes. Tell me.
सर ये पैरेलल पाथ बिटवीन टू ब्रशेस जो कैसा दिखता है सर वो?
कैसे दिखता है? Okay, मैं दिखाता हूँ. Suppose this is a these are two brushes. Suppose these are two brushes, and armature are there. Suppose this is an armature and two brushes are there. Suppose one current is coming like that, and all the armature have here are the conductor. They are connected series. Like that. So now tell me how many paths we can provide between two brushes. Suppose a current is coming towards there. How many paths we can provide? One is provide can by upper side, and one is can also provide by lower side. So the minimum path should be two. Is it clear now? Is it clear now?
Okay, sir, but what is a parallel path?
That means suppose one current going from that way, then from this bus, the how many paths are there from this bus to that bus? How many paths?
Two.
Two. These are the parallel path. These two are parallel path. Have you get my point?
Okay, sir.
Then suppose I make another path. Now tell me how many paths are there?
Four.
Four. So we can increase like that, and it should be multiplication of two, because one path is should be there and another should be there. One is in upper half and one should be in lower half. The machine are designed such that if the number of parallel path is 2, so this type machine is called wave, and if the number of parallel path is equal to the number of pole, then this type machine is called lap. I hope you have understand what type machine is called wave and what type of machine called is called lap. I hope it is clear to you now. Ayush,
Yes, sir.
so tell me, uh, which machine is called lap?
इसका
Suppose
number of parallel paths poles के बराबर होगा.
number of pole. Yes, good. Suppose I have a lap type machine. That means the number of parallel path in that machine is number of poles. And how to remember that? Either the number of parallel path is 2 or p. And how to remember the lap type? Because in the lap word you can see there is a and p. You can see easily see that there are two letters in lap. One is a, another is p. So you have to remember that a is equal to p. That is lap type. That means L A P. A and P are in the words are in lap. So we have to remember like that. Can you remember that now? Which is called lap type, or how to remember that? Ayush?
Yes, sir.
That means lap type is A is equal to P, and in lap there are two letters. One is A and another is P. So we know that there are two types of machine. One is A is equal to 2, which is called wave, and another is A is equal to P. So in the lap word, A and P are there. So we can easily remember that which one is lap and which one is wave. Now we move to our next topic, the characteristics of DC generator. Now we move to the next topic, characteristics of DC generator. Now the next topic is the characteristics of DC generator. first characteristics is called magnetizing characteristics. Please write down the first characteristics called magnetizing characteristics. Magnetization characteristics. The second one is internal characteristics. And number three, external characteristics. That means there are three types of characteristics. What are these? Ganesh, tell me what are the what are the characteristics of DC generator? Ganesh, Deepak,
Yes, sir.
what are the characteristics of DC generator
Magnetization characteristics, internal characteristics, and
and
external.
external characteristics? Good. What are the magnetic characteristics? And actually, what are plot in magnetization characteristics? We plot, or we can say that the magnetization characteristics is open circuit characteristics. This is also called open circuit characteristics, OCC. This is also called OCC, open circuit characteristics. What we plot in that, we plot between the generated voltage and field current or excitation current. We vary the field current, we vary the field current, and how much voltage is generated, we plot on in a graph. Then we this call that call the magnetizing characteristics or open circuit characteristics. And what in internal characteristics? What we do that, we do here, we do here a graph between generated voltage and load current. We make a plot or make a graph here of what generated voltage and in between generated voltage and load current. And in case of external characteristic, what we do, we plot between terminal voltage and the load current. This is terminal voltage and this is load current. Manish, now tell me what is magnetization characteristics? Manish,
Sir, please repeat the internal characteristics.
Manish, are you there? Wait, Deepak, wait. Manish, Khushbu, have you understand what is magnetizing characteristics? Khushbu,
Yes, sir.
now tell me what is magnetization characteristics? What we do in magnetization characteristics?
Sir, sir, can you repeat it? I can't understand.
Okay, and let's see in other who have understand or not. Praveen, have you understand that? Praveen,
Uh, so I have a confusion on that. What is that? EGIF? What is that?
okay. Shamshad, have you understand that?
सर रिपीट कर दीजिए एक बार.
Okay. First, what we get? First, we suppose I have a machine or I have a DC generator. Suppose I have a suppose I have a generator. What kind of generator it is? Tell me anyone. What kind of generator it is? Tell me what kind of generator it is.
Sir, mutual induction generator.
How many types of DC generator are there?
Three.
Three. Based on
Three
excitation, how many
shunt and
types of DC
compound.
generator are there? Tell me.
The series shunt and compound.
These are self-excited.
Sir, self-excited and separately excited.
What?
Self-excited and separately excited.
Good. There are two types of DC generator based on excitation or types of excitation. One is called separately excited, another is called self-excited. Which kind of DC generator it is? What kind of DC generator it is? Tell me. Self-excited or separately excited?
Separately excited.
Separately excited. So first we excited the field coil. We excited the field coil by uh, flowing the field current IF. Then this armature rotating with a speed so that a voltage is produced here. And how much voltage is produced here? Can anyone tell me? Suppose this is the shaft. of the DC generator, and it will rotating, and a voltage is produced. How much? Eg on that armature. Where the voltage is produced? What is that section where the voltage is produced of DC generator?
Armature.
Armature. That means in, and which one is the armature in the diagram?
Circle part.
Which one?
Circle one.
The circle one. Good. And what these two? Tell me
Process.
what these two?
Carbon brushes.
Brushes. These are brushes. Good. Then if we excited the DC generator and if we provide mechanical energy in rotation motion, then a voltage is produced. How much voltage is produced here?
EG.
Ag. Then what is called magnetization characteristics? Suppose we plot a graph. Suppose we plot a graph. Suppose we plot a graph between Eg and Eg and in between field current. How much field current is provided and how much generated voltage is produced. Then we make a graph between these two quantities. Then these characteristics called open circuit characteristics, and it's shown like that. If we plot between the generated voltage and field current, these characteristics called magnetization characteristics, and it's in like the curve. This is called OCC curve. I hope it is clear now to all of you.
So what is the full form of OCC?
Open circuit characteristics. Just write down the full form of OCC is open circuit characteristics. This is also called magnetization characteristics.
Sir, IF input current है sir.
IF is field current. IF is field current.
What sir?
Field current. And what is EG? Generated voltage.
Generated voltage.
And where the voltage is generated? What is the part? What is the name of that part?
Armature.
Armature. Good. Then if we flow the field current through the field, then a flux is generated on field or pole, then armature conductor are cut by that field and a voltage is produced on armature. And how much voltage is produced here? The value of voltage is Eg. And what is the expression of Eg? Can anyone tell me what is Eg? What is the expression of Eg?
Pn phi Z by E.
P I N Z by 68. And if you say the small n, then you can say P phi nz by A. That means that much voltage is produced. And suppose I have a coil. Suppose I have a coil. How much flux is produced on that coil is proportional to which quantity? Suppose this is Fi and number of turns of that coil is N. Then you tell me how much flux is produced on that coil and which quantity are proportional to the flux. Can anyone tell me? Can
The
anyone?
flux is proportional to number of turns.
Number of turns and current. How much flux is produced is proportional to the number of turns and current. If the number of turns is constant, then we can write proportional to I when n is constant. So the flux is proportional to the current. You can easily see that in the expression of Eg is there is a phi. That means we can replace the phi by If. Can we replace that? How actually we do that? Eg is equal to E phi n j by 60. Suppose a machine is designed, already you have designed, then the number of poles is constant and the total number of conductor is also constant and the number of parallel path is also constant. So we can write like that a constant in like that. When a machine is designed, already it has already designed and there is a machine, we can say Eg proportional to a constant phi and n. If we rotate that generator with constant speed, suppose the speed is constant here, speed or constant speed, suppose is constant speed, then we can write Eg is equal to constant and phi. So we can write Eg is proportional to field current. Can I say that? Because I is proportional to the field current. Can I say that? Khushbu, can you understand how actually we do that?
Yes, sir.
Praveen, have you understand?
Yes, sir.
Then,
But sir, conclusion that where phi equals directly proportional to Ni, there you're taking the number of turns. Okay, sir.
if we taking the number of turns is constant, then we can say I proportional to field current.
Yes, sir. But there you're taking the number of turns. But either way, that here Eg equals to P phi n2 by 60. There you're taking n equals to n is constant speed.
Oh,
There I have a
here in is actually speed in case of EG, but and if it's make a confusion in you, so please just take it T number of turns. it make it confusion to you, then just it write its T. Otherwise, it may be confusion, create a confusion. So it take it T. T is number of turns.
Okay, now,
Now I hope it is clear to you.
yes.
We are taking T is number of turns. So I hope you have understand what is magnetizing characteristics and how actually we do that and how the EG depend on IF. I hope you will understand at that. Have you understand, Danish? Have you understand?
Yes, sir.
Okay. Then we move to the internal characteristics. What is internal characteristics? What is internal characteristics? And suppose we make a plot. We make a plot between EG and IL. What is EG? What is EG?
Voltage in armature.
The voltage which is induced or produced on armature. And what is IL? What is IL?
Load current.
Load current. And it actually seems like that. When the load is increasing, the induced EMF voltage is smallly decaying. And after that, we have to plot the terminal voltage and the load current. What is the name of that characteristics?
External characteristics.
External characteristics. And can anyone tell me what is the relation between EG and V? Can anyone tell me what is the relation between V and EG? Have you remembered the equivalent circuit of DC generator? What are Have you seen that ever? Have you seen the circuit like that? What is this? Anyone tell me what is this? Deepak, what is this?
EG is
Ayush, tell me what is this?
EG is EG is induced EMF. VB is brush voltage.
Yes. Cross voltage drop.
Uh,
RA is
IA is current.
IA is armature current. RA is
Armature.
armature resistance. And this is called the equivalent circuit of a DC generator. This is called equivalent circuit of DC generator. And from that equivalent circuit of DC generator, by applying KVL, what we write? EG is equal to, suppose the load or terminal voltage is V. Suppose the terminal voltage is V. Then we can write EG is equal to V plus IA RA plus VB. If we neglect VB, then we can write EG is equal to V plus IARA, neglecting VB. And this is called the generator equation. You can say that this is called generator equation. Please write
So
down.
VB को neglect क्यों किया सर?
Yes,
तो उसको neglect क्यों किया सर VB को?
क्योंकि ये जो वोल्टेज, ये जो दो वोल्टेज होता है ना, ये ईजी जितना जनरेट किया, ये टर्मिनल वोल्टेज हुआ, इसके रेस्पेक्ट में ये वीबी का वैल्यू बहुत छोटा होता है. माने with respect to EG and V, the value of VB is too small. So we neglect that VB. When we neglect a term, tell me, you have also learned in physics. When we neglect a term, physics in mathematics, we have neglected so many terms. And when you neglect a term,
So if that quantity is very small, or
very small with respect to other quantities. So
yes,
here the VB value of VB is quite small with respect to EG and VB. So we can neglect the VB. So we can write EG is equal to V plus IARA. This equation is called generator equation. And from that generator equation, we can easily see that the value of EG and V, which one is greater? Which one is greater?
sir EG.
The value of EG is greater than V. So if we plot between EG and IL and V and IL, if we plot whose value is greater at a particular load current, EG or V, which value are greater for a particular current? Here you can also write the IL is equal to IA. You can also write because See that this is armature current and this is load current. They are same path, so we can write IL is equal to IA, and the value of Eg is higher than V for a particular armature current. So the suppose we are considering here. Suppose consider that point like that. We can easily see that the value of Eg is greater than V, because we know that the equation is Eg is equal to V plus IARA. Deepak, now I hope it is clear to you. Deepak,
Yes, sir.
okay, we have to end our class today. So
सर स्क्रीनशॉट लेना
क्या बोल रहे हो?
वो लास्ट पेज का सर स्क्रीनशॉट लेना
समझ में नहीं आया, फिर से बोलिए.
सर स्क्रीनशॉट कुछ नहीं सर हो गया
स्क्रीन दोबारा देना है.
नहीं सर नहीं सर हो गया
ओके, अब अटेंडेंस दीजिए. आयुष कुमार,
यस सर
दीपक,
प्रेजेंट सर
प्रवीण,
प्रेजेंट सर
मनीष,
प्रेजेंट सर
दानिश,
यस सर प्रेजेंट सर
खुशबू,
प्रेजेंट सर
शमशद,
यस सर
यश,
प्रेजेंट सर
मुस्कान,
प्रेजेंट
सुजीत,
सर
सुजीत,
यस सर
असगर,
यस सर
सुमिरन, सुमिरन. Okay, you may leave now. Okay.